wait a bit.
No, it was in December or November. It wasn't that long ago.
Yeah, it was soon. It was like
November?
a couple of months ago.
Yep.
These are special. You can't do them all the time. It's like Glastonbury.
Okay, cool. I've invited Adam up on stage. I think a few people are missing. Do we want everyone up on stage? You go, Adam, or do we invite them after?
Sure. No, we can pick them up.
Yeah. Okay. Come on.
Hide people that don't have their videos on. Can you do that at the stage? You can't. You don't have that setting. Show notification video. No.
Am I missing anyone? I don't think so.
You can't turn those that don't share their videos off.
You can just click on the tab, Patty, to collapse the audience list.
Right, I've got full screen.
Okay, fine, that works. Okay, awesome. Hello, everyone. Welcome to this month's call and this year's first community call. We've got a lot to cover today. I just wanted to say before we start, as always, you can drop your questions down in the chat or on the Stage Questions channel. If there's nothing else, I guess we can start. So we'll be starting out with a chip update from Adam and Patty. I don't know which one wants to go first, Adam or Patty?
Why doesn't Adam go first? Go on, mate. Then I'll talk tech.
Okay,
you talk on tech, and I'll do tech.
Exactly. So so we have been we've basically finished the first project that we have initiated to develop Minima on Chip. It's been very successful, and we did in collaboration with Southampton University. So it was a design project. Master's students worked for 3 months to try and get to come close to the first prototype build of Minima running on very low-powered devices as our prototype for building Minima on Chip. So that's our long-term vision, and we'll explain a little bit more of details in Hugo's update. But suffice to say, the project was very successful, and what we're trying to do with all of these projects is to actually give real-life demonstrations of Minima running in environments where no other blockchain can function. So the challenge was set that the students had to work on different parts of the project. One was to make Minima, or was to transpose Minima as a Java script into a C++ language, which is the stepping stone for bare metal development. So chip design is going to rely on C or C++ code without the libs. Paddy can explain more detail. And that was the first challenge. And second challenge was to actually build a proof of concept. And the concept we chose was using Minima embedded in drones. And drones are becoming ubiquitous. They're used in many applications, including delivery. And as drones are becoming more and more used, there's a regulation and a compliance requirement for making sure that you can capture and store and utilize the data in real time by drones. And so that was the challenge. Can we actually run a Minima node, an incredibly low powered device? And we were successful. So in January this year, we actually demonstrated a drone running Minima, communicating with a land-based node, and storing and hashing the data on chain, which was then recorded on with Integritas. And included in the demo was the generation of an NFT as a certificate to fly, and sending that NFT from the controller to the drone. The drone held it by the time all the time that it was in flight, and then on landing it sent the NFT back again. So we did a full scope project, and the students ended with their design project, and we did a lot of benchmarking in the process. So we've learned a lot, and we've got we've ticked the box at the first stage of Minima on Chip.
Yep. Thanks for that, Adam. So just to say, obviously, when NVIDIA make their chip, It's not like, yay, we've done it, we finished, we don't need that anymore, get on with it. As Adam says, this was a version 1, and it was really a proof of concept, and it is possible to put Minima on a chip, and that's really, I think, what it showed. Obviously, as soon as you never know how these things are going to turn out, but as we were using it, lots of other better ways of doing it popped out, and that is going to take time to sort of optimize and make it better. But the bottom line is it was like a 100 megahertz board, like a really, really slow board. It's like a DX90. We're talking 30 years ago. And it was running, low power, low memory, all that stuff, blah, blah, blah. But, we know Minima is compact. It runs on your phone, it runs on this, it runs on a Pi, and it ran on the chip. So that was wonderful to see. Well, I'd just like to shout out to the Southampton boys. They were really impressive. Yeah, really impressive team. Very smart, great tech, really sharp. I'd really love to sort of hire them. And like nobody knows about as much as Minima as they do, to see if we can continue to get them to work on it. But that was really good. It's a really good process, and it's also quite nice to sort of try and integrate with the real world. Not just Minima enthusiasts. They weren't NGU people. They don't care about number go up, any of this stuff. They're like, look, we're engineers and we're trying to get this to work on a device and la la la. And I think, as I mentioned in my little dev rant call, the most impressive thing was, we got it running on the drone, but once the drone took off and it was flying around, you're not connected to the earth in any way. There weren't any wires, there weren't any cables. It was just flying around, running Minima. And I think that was a really good visual representation of what we're trying to do here. It's not the drone itself that is like, this is it. We're just going to put it in loads of drones. It's like, wow, we can actually be disconnected from everything. And that was an independent unit. When you take that further, it means that each of you could have your own drone, and they could then be used somehow in some collective, distributed, decentralized way of delivering goods. And, you pay the drone, so there's no like server that can go down, or, and as Ad was saying, at the end, we had this sort of authentication token that we had to send the drone to tell it that it could fly or it couldn't fly, which was all done independently. It was very sort of autonomous. If we stuck an LLM in there, I'd be scared about what it could do. So, very impressive. And I think we're going to try and continue that. Yes, getting it on the C and C++ versions, so close to, we didn't. Eventually, we just had to use the JVM code, squashed down. We just had the class files and we're interpreting that on the chip. But obviously, when he says bare metal, what that means is that you can run just Minima, without having to run a JVM, without having to run an operating system that loads the JVM and then executes the bytecode, et cetera, et cetera. And if you could just get it in the C and the C++, just the system we were doing was like 1,000 times faster. And if you could do it with the bare metal, so you could compile it to run directly, it means you don't have it, just the assembly code of the machine code of the chip. That's like, the speeds that we're talking about here, we can't really understand just how much faster that would be. Not that it even needs to go that, it's not like it was putting it under stress, but it just means even less power would, even less, we could just make it run much more efficiently. So that's why we were trying to get the C++ version. But as I mentioned, I have a feeling that's going to require a rejig of the Minima code. The Minima code base is like, when you look at the jar, it's like 80 megabytes. I mean, that's mainly the mini dApps, frankly. Without the mini dApps, it's like 50 megabytes. Then you get rid of the mini dApp system, and it's like 20 megabytes. And you get rid of Maxima, and it's like, oh, so if you're talking just Minima, when I was compiling the optimized version of Minima that I call, there's a branch of it in the GitHub, it's called Dev Pure Minima. The jar of that is like 1 megabyte. 1 megabyte for the whole of Minima is the actual jar that actually does the brains of Minima without any of the other stuff. Because it's important to remember that the Minidapp system, that Maxima, these are not, they are our, additions to Minima, but they're not part of Minima. They can be upgraded. They can be changed. Minima itself cannot be changed. That's fine. But the Minidapp system, I'm looking forward to a Minidapp V2 system, learned a lot. Looking forward to a Maxima V2 system, push and pull so I can get a response from a message. And those things can totally be done without breaking anything. You just need to write those versions. So it's good. It was really nice to strip Minima back down to its core essentials. Even in those core essentials, it sort of stood out how, KISS VM should be a lib. The KISS VM, computer scripting language that we use on Minima, that should be a separate thing with its own unit test, with its own everything. That's something. Then the ghost heaviest branch algorithm that we use to tell which is the longest chain, that should be a lib. Then the brains that do the consensus, that should be a lib. And if you had that, it'd be so much simpler to get the C++ version, because just giving the whole box to an LLM and saying, come on, man, convert this into C is quite complicated, even for me, let alone an LLM. Whereas if you had little components and it's like, right, let's go through it. And the main thing was that at the end, it was tough to find the bug. Why it wasn't crashing or anything. It just wasn't working. It just wasn't, we got 95% of the way there. And even in testnet, it worked. It was totally fine. But then on mainnet, something wasn't working and it wasn't crashing. It's like, that's the heart of coding. That's the heart of what we do. And it's like, how do you find that bug? And if you'd had it chopped up into different components, it'd be much easier to find them. So yeah, lots of doors were open. It was really nice to see it working. And it was just an exciting project. It was good. It was good to see.
Yep.
So looking forward to more of that. Shall I have a quick chat about... Yeah, sorry.
No. We're gonna move on. On.
Okay. Not the decks, no.
Not yet.
No.
Don't worry. We'll come to that.
All right. It was good. It's fun. It's good.
Hugo's going to give us an update on the fundraising announcement that we're going to be making soon. Go ahead, Hugo.
Yeah. Hi, everybody. Great to see everyone. Thank you for coming, as ever. This is not merely a sort of fundraising update. It's also, I wanted to sort of take you through how we're now positioning Minima to potential investors, both within crypto, but also crucially beyond crypto and Web3 into the sort of enterprise realm, and also this fast emerging world of that's being shaped by the convergence of AI and machine autonomy. And so that's what I'm going to take you through. As ever, there have been lots of good questions raised by the community in the stage questions. And most of these I will cover off in this presentation. So let me just bring this up. Hopefully you can see that now. Streaming. There we go. Okay, perfect. So I first of all wanted to sort of start by grounding this presentation in first principles, because this slide captures the problem that Minima has been designed to solve. So the first blockchain designed for 1 billion nodes, building a trust layer for autonomous machines. When we began Minima back in 2019, the focus wasn't on headline metrics like TPS or throughput or fees. It was on a much deeper question, which is, what does decentralization actually look like at global scale? Because most blockchains, as we know, centralize as they grow. So the more users lead to larger infrastructure requirements, which leads to fewer operators and eventually a smaller number of powerful intermediaries, which is, of course, in what initially blockchain was supposed to get rid of, but actually it hasn't actually done that. And so Minima was designed to do the opposite of where everyone else is going. So by enabling a full node to run on every device, the network becomes more decentralized as it scales, because decentralization is tied directly to hardware distribution, not governance or permissions. And so that design now has been proven in production. We've been live since 2023 with 100% uptime. And over the past year, that same architecture now has been extended beyond phones and into silicon, which is, as Paddy and Adam were just talking about, very exciting step. And this materially changes the scale and relevance of the network. So, as AI systems and machines increasingly transact autonomously, trust can no longer be delegated to platforms or centralized infrastructure. And so it has to be generated at the edge. And so over the next few slides, what I'm going to do is I'm going to talk you through what we've already built, what's changed over the last year, why moving Minima from phones to silicon is a major step change, and how we're now entering the commercialization phase with real products and revenue streams. Now, obviously, I know those of you in the community who come to the community and the channels a lot will know a lot of this, but I think it's good to sort of see how we're positioning it as an overarching approach and what we're saying to the outside world. So let me sort of kick off now. So what we're looking at is Minima is a truly distributed layer. Minima is the world's first blockchain to run in full at the edge on any device. Initially, mobiles were the lowest hanging fruit to enable anyone to run Minima and to build the early community. Since then, obviously, we've progressed to cars, as you'll know, IoT equipment, routers, and as we've just talked about, in the very near future, directly onto microchip. So 6 months after mainnet launch in 2023, we turned off all our centralized servers. So this means that the entire network now runs completely at the edge, currently live on thousands of devices, every single one a fully constructing and validating node. It's true decentralization. And so, as I said, we've had 100% uptime since mainnet launch, and it's been great for building trust with other real businesses that are looking at adoption. And Minima achieves consensus at the edge through collaborative rather than competitive proof of work. So every device does a small amount of work to mine their own transactions. There's no need for centralized miners or stakers. And so really what this leaves us with is a blockchain that's literally scale with the hardware of the world. So that, you know, as the network grows, so does the hash rate and so does its distribution. So our next step, obviously, is, as mentioned, to go even deeper now into the hardware itself. So working with Arm, Siemens, and Southampton University, we've just completed a native deployment of Minima Node within a microchip environment. And this is a full node executing directly on Arm-based systems. And of course, Arm IP is present in 90% of all devices, which represents a massive total addressable market. And with Siemens, we're working directly to bring that capability into industrial robotics, drones, and IoT environments, where machines can verify data and communicate securely on device and on chain. And the network benefit, as Paddy mentioned, you know, the network benefit of the chip integration is immense because once optimized, we will see 10,000x hash rate improvement over the phone. So, you know, that is you know, a huge amount of improvement and just makes everything on a completely different scale. So on millions of billions of devices, it will generate a huge amount of insurmountable hashing. So obviously before we've always worried about, you know, a phone is not that powerful. So actually it'd be quite easy to replicate that. Whereas if you imagine a billion devices running at a 10,000x more efficiency, then, you know, you can do the numbers on that. There's a huge amount of hash rate security there. And so it really means that, you know, Minima is the world's only fully embeddable public layer one blockchain. And I think that, you know, the conversations we've been having as we've now been progressing to reduce the form factor of Minima, we're really stretching ourselves away from the rest of the pack. We're not just another blockchain, we're a blockchain that exists at the edge. And that's something that we're finding really resonating with potential investors now.
Yep.
So, you know, today's reality is that we're entering the decade of AI and machine economy where the two are going to merge. So soon you'll be paying for a car will pay for its own charging. Your fridge will order its own supplies and your AI assistant will negotiate services and payments in real time. So billions of devices and AI systems will then transact all autonomously without any human in the loop. But of course, there's a challenge because machines can act, but they cannot trust. So data can be manipulated, AI outputs can't be traced, and when one system sends a signal to another, there's no independent way to prove that it's real. So for this economy to work, every single interaction has to be verifiable, automatically and efficiently. And the most efficient and programmatic way to do this, of course, is on-chain.
Yep.
So the only way to make machines truly autonomous is to let them run their own Minima node. That's why we've built Minima, because we wanted to be able to run directly on device so that phones, cars, routers, machines all validate for themselves at the edge. And this is the key advantage to Minima's design. Trust is generated where the data and interaction actually originates. And so Minima provides the foundational infrastructure for the machine economy in a way that no other chain can. So everything that I've sort of mentioned so far already exists. So at the core is the Minima blockchain, which is fully scalable network, perfect for embedded systems. And the protocol is stable and complete and will power everything that we do going forward. And on this foundation, we're launching 3 commercial products. First is Integritas. This is our data verification platform, and the guys will go through an update of it later on in this presentation. Or in this call rather. And so what it does is it allows enterprises and deep in builders to anchor proofs of machine data directly on chain. And it also includes an efficient search engine that lets everyone independently verify a data set against these proofs. Second is obviously Minima on chip. This unlocks major regulated industries for us by allowing Minima to run fully embedded within machines, because it's a crucial requirement for scaling into regulated production environments such as automotive, industrial IoT. And so, what we can do is we can effectively isolate the blockchain functionality from the rest of the critical tech stack. And this will make us like the NVIDIA of blockchain. And the third is Omnia. So our off-chain transaction scaling solution effectively removes TPS limit. It uses the L2 upgrade to Bitcoin's Lightning Network, and we've already piloted it across border payments between London institution and a Tanzania money transmitter. And together, so these products will generate revenue for Minima AG, which is the issuing entity, while creating ongoing demand for the Minima token.
Yep.
So how do we make money? So Minima AG will drive revenue across software, hardware, and payments, all powered by the Minima network. So Integritus runs as a SaaS and API-driven platform where enterprises can deploy the tool to anchor and verify machine data efficiently and cost-effectively. Minima on chip will drive OEM licenses and royalties. And our goal here is for it to become the industry standard for embedded blockchain, which will generate long-term high-margin growth and a moat for us to really protect our product. And Omnia, obviously, that will be monetized through API consumption and settlement as a service for industry partners. So with each of these products, they all stand alone commercially, but they strengthen one another. And so together they form a complete and interoperable stack of trust, verification, and settlement across the machine economy.
Yep.
And as adoption grows, it's very important to understand that value builds on two levels. So at the network layer, every node, transaction, and interaction increases security and activity, creating organic demand for the Minima token, which has a fixed cap supply. There is no extractive mechanisms, just genuine value driven by the real network use. And at the company level, Minima AG captures enterprise value through OEM integrations, licensing, and industrial deployments. These generate recurring revenue and long-term strategic relationships. So both sides strengthen each other. So network growth drives token demand and commercial adoption expands the ecosystem. So it's a self-sustaining loop, and we think that it's the right way for Web3 going forward. And we've discussed this with investors, and they really now understand how those two things can be mutually beneficial to each other. So the final slide from me here is that, Minima isn't the best known chain yet, but we believe it's the exponential one. And this is the conversation that we're now having with investors. So we're now raising a $3 million safe note capped at a $15 million post-money valuation. The issuing entity, AG, holds all IP and the Minima on chip technology and drives the commercial rollout. And it also holds 10% of the fixed token supply reserved for long-term shareholder value. And this round will scale commercial adoption, advanced chip fabrication, as we discussed, and it also increase the value of the treasury for shareholders. And we'll also use this round to position a successful Series A in the second half of the year. Because obviously, once we start we could be working with Arm and Siemens in terms of approaching their customers with our product. And that will then really give us a great sort of building block for us to then head to a Series A later in the year. So we're starting conversations with both crypto and wider deep tech infrastructure VCs. And we'll also be running the raise on a major crowdfunding platform. So the community can participate as well. So you can get exposure both to the equity and to the token as well. So I think that hopefully that all makes sense. And I think it should have answered quite a lot of the questions raised in the question on the stage questions. But again, hopefully it gives you a really good understanding of how we're positioning ourselves. And I think hope you'll agree that it really positions as a place of strength to differentiate ourselves from the market, and also shows how much we are now literally at that perfect tipping point where AI and machine economy is coming together, and they need that trust layer. And unless that trust layer can sit at the edge on the device, then it's always going to be weakened by centralizing features that other blockchains have, and that we have avoided right from the beginning by design. And so, yeah, we feel very vindicated. It's taken a long time, this journey, but we're feeling more and more positive at what the future holds. So, thank you for listening, and I'll hand back to Neo to continue the updates.
Thanks a lot, Hugo.
Yep.
That was a long and very detailed presentation. I enjoyed watching it personally. I know others did, because Mr. Plainview said it was always a pleasure listening to you. Now, moving on, we've got an Integritas update from Adam and the Integritas team, which are Rasmus and Natalie, that you'll see on stage with us.
Okay.
Yep.
Very good. So, as Hugo mentioned, we are moving forward with Integritas and bringing it into enterprise-ready products. So on stage today are our lead devs, Natalie and Rasmus, who will talk you through the inception and the architecture and our rollout plan for our enterprise solution. So just as very quick background, I mean, Integritas was born out of the need for securing data. Regulatory and compliance constraints are requiring that people become more secure with their data. And our original collaboration in the automotive space around the need and the regulations for all new cars produced from 2026 onwards to have black box or data recorders in the case of an event or a crash has meant that there is a demand and a requirement to have an immutable storage of data. So this project was born out of the idea of, could we put a blockchain node on any device that could actually hash data in real time at the source of production of the data, and importantly, be able to then query that hash later on. So this was the background, and the output of that is this product, Integritas. So I'll hand over to our devs who will talk you through the products.
Yep.
Natalie.
Yep.
Thank you, Adam. I'm Natalie, and Rasmus and me are going to share what our dev team has been working on. We're going to walk you through how Integritas works, the architecture, and the MCP integrations we just released. And a problem with data stored in conventional databases is that they can be modified or deleted by administrators. The issue is that people maintaining the data have power to alter them, and Integritas solves this by hashing data and anchoring it to the blockchain, where it's permanently locked. Integritas was built to provide a secure layer of trust for important data. It is a middleware solution that connects applications to the Minima blockchain. And Integritas creates an immutable cryptographic proof that can't be backdated or altered.
Yep.
And there are two main functions that Integritas uses. So we have stamp function that takes file data, creates a hash, a unique cryptographic fingerprint of a file, and anchors it permanently to the Minima blockchain. And then we have the verify function that takes file data and hashes it as well. Then it searches the blockchain to see if it was previously stamped and generates a detailed report proving when it was originally stamped and that it hasn't been modified.
Yep.
The Integritas user dashboard, it gives you an interface where you can monitor your tokens. We wanted to make this accessible, so every user gets 50 free tokens when they sign up, which is enough to test it and see how it works. And I will hand over to Rasmus now to explain more about the underlying architecture and integrations.
Yep.
Thank you, Natalie. Hi, everyone. I'm Rasmus, and I will speak about the Integritas API, how it started and how it has evolved and been developed along the way. I will go through its internal components, the external integrations, and some basics around authentication and user interaction. So, looking at the building bricks that make up Integritas API, there are 4 main components. We have the core API, which is the orchestration layer, and it is protected from access unless a valid API key is provided. And the API key is fetched from our servers in different ways, depending on the requesting app. And we will look closer at that as we go through the different external integrations that we have added. So if a user requests data to be stamped, the core API receives the request and then forwards it to the timestamp API, which was originally developed by Paddy himself. If a user requests data to be verified, our search API will handle the incoming file and search for matches with help from the Explorer API, and then return a verification report. And the Explorer API itself, it indexes the Minima blockchain and is quick to find what the search API is looking for, which is, does this hash exist in any block on the Minima blockchain? And the Explorer API was originally developed by Dynamite Sushi. The first integration that we added to the API was Integritas Plus. And the authentication process for users is very simple. They just use the same login as they have for our website, and the system will fetch the API key automatically to allow you access. And everyone can use their 50 free tokens here every month. To use Integritas Plus, you just drag and drop the files that you want to have stamped or verified. And the app also keeps a history of your prior stamps and verifications. If you're a developer, you might be interested in testing the Integritas API directly. And you can do so through your normal tools like a terminal, the Postman application, or even at our documentation website. You just bring your own API key from our website and include it in every request. So this is a look at our documentation, and you can see here we list all of our endpoints. And note that there are version 1 and version 2 endpoints for both stamp and verify, and they function a little bit different. And over here there's also the demo function for each endpoint, so you can try it out directly in the documentation website. And this is how a Postman response can look like when interacting with the Integritas API, which you might recognize if you are a developer. The second app integration we have added is a custom GPT, an AI agent, which allows anyone with a ChatGPT account to interact with our API using natural language. We have provided this agent with a no-limit API key, which means that anyone who uses it does so totally for free. And the ChatGPT account is of course free as well. So no subscriptions is needed at all to use this agent to stamp or verify data. And the custom GPT also analyzes and returns a natural language response of the verification process. Anyone can build an application and plug into our API. An app developer would subscribe to Integritas to get their API key and can in turn choose how to monetize their users of their own application. One such project that we know is in development is an AI logging tool that aims to help companies be compliant with EU's AI Act. Our next upcoming integration is with REL AI. They have an API marketplace, and we will later today have an announcement about our partnership launching today. On REL AI, people pay directly for every API call using cryptocurrencies. REL AI has a no-limit API key to us, and users are allowed access to us after their one-time payment for every call is processed by REL AI. We have built a MCP server which lets users of apps like ChatGPT, Claude Code, or Cursor use the Integritas API. Users log into our website to authenticate with the AI tool. And the authentication process is super simple. Just add our MCP server URL in the AI client, and you will be redirected to our website to log in, and the AI client will get your API key. So I will let Natalie explain a little bit more about MCP.
Yes. So MCP stands for Model Context Protocol, and you can think of it as the USB for AI. It's a standard that lets the AI assistant connect to external tools. And the MCP layer is a layer that we built on top of Integritas API, making our tools accessible directly through AI conversations. Users can ask their AI assistant to stamp or verify a document without leaving the chat or opening our website. And as mentioned before, Integritas was part of the Ship on Drone project, where a Minima node ran on board a drone. Flight data was successfully recorded and timestamped directly on the drone. And with this data permanently recorded on the blockchain, it can be verified in different ways, depending on what the client needs. And one way to verify drone post-flight logs is using Integritas through our newly built MCP. And here's an example where an AI assistant uses a drone MCP to retrieve data from the drone, and then uses Integritas MCP to verify that data, confirming the data was stamped and it hasn't been tampered with. And the complete process from retrieving drone data to blockchain verification happens in one prompt directly in an AI conversation. And that was everything for us. Thank you for listening. You can find out more how to use our MCP and other services in our documentation.
Thanks, Natalie.
Thank you, Rasmus. Thank you, Natalie.
Thanks, Rasmus.
Very, very nice. And as you see, community, we've come a long way in a short time with this product. So very happy to take this forward. And there's a question coming up later about the commercial route. So I'll address that then.
Thank you very much. It was a great presentation. So moving on, Adam and I will be giving you an update on the Edge Pioneers program that happened at the end of last year and how that's going and how it's going to be proceeding forward from here on out. Adam, do you want to go or do I start?
You can start, Neo.
Okay. So our team was very involved from the get-go with the program. In my opinion, it turned out really well, especially towards the end of the year when we had the grant calls and we saw the pitch decks of each team. It was all very promising, and it's gotten better throughout the month of January as some teams have kept innovating and sort of branching out their ideas beyond the scope that they had initially promised. So we're still working with these changes, but at the same time, we've been very busy with the chip, which is why there hasn't been any news. I know that now we're going to start moving forward with certain discussions with these teams, and you'll be hearing a lot more about them, I assume, towards the end of the month and next month, as we will have co-marketing activities with them.
Yep. And so just a little bit more flavor on that. There were 40 applicants originally for the Edge Pioneers program. We had 12 that joined us for the full event, and 4 of which were selected as recipients of the grants. And these are now being finalized and will provide a grant over a 12-month period, and that will contribute to development of an MCP, of an MVP, a minimal viable product, prototype, and then marketing. So we are incredibly impressed with how far these teams came, with pretty much very little technical guidance and support. They've come up with very practical use cases. So in the next call or upcoming events, we will invite them each to present their products. So rather than present them here today, we'll let them show you all the demos. So this is a great first developer program, and we are in plans to repeat it and hope to get traction of real people, real developers building products on Minima.
Yeah, I wouldn't have said it better, to be honest. Although I'm very excited for you guys to all see what they're building. Moving on, we're going to cover now the DEX and the stablecoin update. Probably something that you've all been waiting for. I think maybe Hugo, you can start off, and then we'll let Paddy sort of.
Yeah. So I'll talk about the stablecoin, and Paddy can talk about the DEX. So on the stablecoin, making good progress. It's been in testing with community testers. All is going well. Now the only final hurdle is just all of the jurisdictional legal paperwork that we're going through. But all of that is all looking good. So effectively what we have with the stablecoin is a USD bridged onto the Minima network. And I'm very happy to say that we've spoken with Tether, and they've approved for us to call our token USDT. So we will have, like any other chain, our own USDT token that will be on the native Minima network. So you won't see a strange name for the token. It will literally be USDT, backed by USDT on the Ethereum network, on the Minima network. So again, that is now only weeks away. And so thank you for your patience, but we're very excited that that's now coming to fruition. So yeah, Paddy, do you want to give a quick update from your side on the DEX?
Yep. Just to clarify the technicals of the USD bridge, the reason this is different from Miniswap is that instead of having an open market where all of you can buy and sell your USDT to each other, we have one entity that just has a whole load of the Minima USDT, and you just swap with them. So it's 1-to-1. You go to the website, you send us USDT, and then we send you the Minima USD token. Or the other way around, you send us the Minima USD token and we send you the Ethereum USDT. Very clean, very simple, works really well. It kind of makes me think whether Miniswap could have been done slightly differently, because I know Miniswap was a bit of a mare in terms of its, more the UX really, and the UE was interpreting the UX, but it was quite complicated, the Miniswap system. This is a much simpler, much cleaner version, which just allows you to cross-bridge this stuff, which is really nice, and that's functional. And as Hugo says, the technicals of it wasn't actually that hard. It's all the legals. This is why crypto's here. It's so annoying. They make it so difficult to do this stuff. It's just code, man. We're not trying to do anything funky here. It's just a bit of code that we're not allowed to launch because the lawyers say no. But anyway, Hugo's doing an excellent job speaking to, getting the permissions to do that. So that's cool. So then we're going to have that. Then onto the DEX. So the DEX is basically done. and it's working, and we've been testing it for weeks now, and that seems to be totally fine. I'm going to clarify something that I said in the dev talk, because I know Neo's been getting a lot of hassle for this, where I mentioned something about 2 days. And what I said was, if people were listening, was that I integrated a wallet into the DEX. Yeah, so there's the DEX, and then I integrated a wallet into the DEX, so you can send money to the DEX and remove money from the DEX. That took me 2 days to integrate just the wallet functionality into this larger project called the DEX. And the reason that sort of struck me was because of the whole read, write permissions thing on the mini dApps. Yeah, you've got your read permissions mini dApp, and you've got your write permissions mini dApp. And it sort of struck me that I wish I'd never done write permission dApps. And actually what we should have done is we should have made mini dApps integrate wallet functionality into each mini dApp. And so you give a mini dApp a certain amount of money that it can muck about with, and then you know what it's got. And you never need to give a permission to your main wallet. You never need to use write permissions, which sort of absolutely compartmentalizes and sort of secures, all right, I've given this much to this mini dApp. So even if it's a fraudulent mini dApp, even if you download somebody else's mini dApp and they try to run off with it, that's all the money they ever have access to. They never get access to your private keys or your private wallet. That's what I was saying, because actually with the, all of this stuff just uses transaction create, transaction input. Those of you who are devs understand that. It's really easy to add a wallet to a mini dApp. Yeah, send, receive functionality. Here's the QR code, blah, blah, blah. That bit took 2 days. The DEX itself has taken me 3 months to write. Yeah, even I can't write a DEX in 2 days. I mean, I'm good, but I'm not that good. So I know people will be saying to me, he's just knocked this over a weekend. Well, I wish I could, but I can't. It was just that bit of functionality and the way it made me rethink about this whole read permissions and write permissions and how we shouldn't have ever done write permissions. Again, that's not part of Minima. That's just part of the mini dApp system, blah, blah, blah. This is not unchangeable stuff, but you learn as these things go on. I know there are advocates, I can see one of them in the audience, who rightly think that write permissions is a big no-no, and it just makes it complicated because they always have access to your private keys, and that should never happen. So that should have been the way that it does. So the DEX is done now. I've got to say, no other DEX that I know of is written like this. This is the minimal way of doing it. Yeah, we always do things, in this sort of, it's for you. It's not for us. It's not our DEX. It's not Minima's DEX. It's an open source project. Any of you can download this code and whack it up on your website and get it working. Admittedly, I did do a little competition in the testing group to see who could get one of these working, and it proved more complicated. It's just files that you've got to put in your var www.html file, spin up a Node.js DEX server. It takes me 3 minutes, but obviously I need to work on making it even easier. But the whole point about this DEX is that all of you can run one. This is the point. This is what it was meant to be. Any of you can now start a token. Let's say I own a pub and I want to sell shares of my pub to, the point of markets, the reason the New York Stock Exchange started was for businesses to raise capital, to raise money. I offer you shares of my business and I need some money. Then I make money and I pay you. That's what this is for. So if any of you have got a token, any of you build something or you do something, you can whack up a DEX on your site now. Yeah, there's no legal implications because the DEX itself is all done in the client. It's pure peer-to-peer. All the transaction signing, all the messaging, all the cool stuff is done using the MiniMask plugin. You're not involved in any way. You don't sign anything. You don't have any private keys. There's none of that. It's just a relay server that allows communication between different peers that are accessing the DEX. And so the way that this is meant to work is that, yes, we're going to run one and you can access that, but on your website, you should have your own DEX. Also, it's pretty simple. Like there's literally one index.html and then a whole load of JavaScript that you don't need to touch, which means that it should be pretty simple for you guys to skin it. Which means that it should be pretty easy for you guys to make it your own, to make it look like your own, put your own graphics in there and put your own, the way that you think it should be. And I'd love to see that. And in fact, me and Neo were discussing earlier how anybody who knocks one of these up on their website, we will go and puts up their token. We will go and buy some of that token with real Minima. Yeah, there's an incentive for you to get this up on your own website. It also means it's far more resilient, far more distributed and decentralized, because it means that there's no single place that can go down and all the DEXs go down. Yeah, obviously you can just whack your token up on the DEX itself supports any token on Minima, and that's fine. but you can limit that to whatever tokens you want. You can say, no, I only want this DEX on my website to access this token, which is good because it means you can concentrate liquidity. Yeah, everybody who wants to trade that token goes to your website, and everybody who wants another token goes to the different website. Yeah, so there should be, I mean, I'd love thousands of these if possible. I know there won't be. I know this is but it would be nice, and it is now possible for that to happen. It's super easy. It works. We've had I think what's quite important is that we've had no situation where somebody has done a trade and somebody's got the coins and the other person doesn't get the coins. Every trade is one transaction. So either you both get your coins or neither of you get your coins. There's no scenario. I don't pay him and then he pays me. It's like we construct a transaction. We verify the details of the transaction in the client. And then when you're happy, you sign it and post it. So it's a really secure system in terms of you're not going to lose your coins, which I think is really important. It's non-custodial, which is very important. There's no KYC, not on our version. It does bring up some interesting questions about if you wanted to put this behind a log-on section of your website. You might have a website that has a username and password to log in. You might only want to let your users trade this, and that's totally fine. You can do what you want with it, yeah? That would actually mean that you only had certain users allowed to use your DEX if that's what you want. If you were trading tokens for some card game or something, or it works with NFTs, yeah, so it works for single units. All of the decimal stuff is worked out, etc., etc. And I'm going to say it's fast, which is really quite interesting. When I did my original dev chat about this, I explained that there's different ways of doing this. We could have done it where everything was on chain, where you had to do an on-chain transaction to update the order book, but that's really slow. Yeah. So what you want is a system where I can just put in orders and take away orders from the order book. And so that's done. And then what you want is you want to say, look, I want that order. And it's like, and I want that to be fast, and that's done. And the only thing that's slow-ish is that when you do a trade, it does an on-chain transaction and you have to wait, 2 or 3 minutes for that transaction to confirm, and then you get it. So order book is fast, execution is fast, but getting the coins takes 2 or 3 minutes. And I think that's a trade-off that I think, works rather well. So works really well. It's really fast. We've had no issues with people losing coins, which is the most important thing, frankly. It's non-custodial, and I really look forward to seeing what happens with this. And more importantly, I look forward to seeing whether people are able to integrate this into their own websites, which is really where this technology should shine. So look forward to that. Thank you.
Thank you, Paddy. Yeah, the DEX has been in testing. It's working out rather well. So I mean, there's still a little bit of work to be done around that, but congratulations, Paddy. You did it.
I'm not this is what I want them to skin it. I want you guys to make it look cool. Yeah, I make it look the way I think it looks really rather nice, actually, Neo. But, obviously everybody has their own opinion of what, whether blue boxes, look nice. Some people think blue boxes look nice, and some people don't like blue boxes. That's like a subjective thing. Yeah.
Yep. It is subjective. Okay, my bad. My bad. I apologize.
All right.
Okay, so moving forwards, we've got Luke with the final little piece of this call. So whenever you want.
Cheers, Neo. Yes. So then, first the crowdfunding element of the raise, which Hugo mentioned earlier on. From our side, this is like a material step forward. It doesn't just broaden participation; it allows us to communicate with a far greater clarity and consistency. Can't get my words out. We can now align the messaging, content, and community engagement directly with the company's direction, rather than speaking in abstractions, which we've had to do out of necessity, but that I know that you've not always been a fan of. From a community perspective, the audience that we have remains highly technical and is long-term oriented. Engagement is increasingly driven by product milestones, particularly Integritas, the DEX, and the chip work, rather than market speculation. That's a positive signal. It lowers noise, improves retention, and creates a base that actually understands the value that we're building. On the marketing side, the strategy is deliberately conservative and credibility-led. In January, we published the From Roadmaps to Results blog post, which set a clear expectation. Minima is going to move away from forward-looking promises and towards communicating what is already working. If you haven't read it yet, I'd urge you to, and you can find it on our website, https://minima.global/blog. That piece wasn't just narrative, it sets the operating principle for how we're going to communicate from now forwards. And you can see that approach in action through the weekly engineering updates that we've been publishing. These are intentionally factual, progress-driven, and tightly coupled to delivery. They serve as a live proof point that communication is being driven by execution, not aspiration. And in terms of positioning, we're framing Minima not as another crypto network, but as infrastructure through 3 clear pillars, which are Integritas as practical AI and data tooling, the DEX as a native resilient financial layer, and the chip work as proof that Minima operates below the cloud, not on top of it. And this framing reduces narrative risk and clearly differentiates Minima from the broader market. Execution-wise then, we are increasingly focused on show, not tell. Upcoming assets include an Integritas video demo alongside longer form content tied to academic and industrial contexts rather than just purely crypto native channels. This approach builds external credibility, and it's going to support enterprise and partner conversations that we're having and extends our reach beyond retail crypto audiences. Finally, community marketing are now tightly coupled to engineering readiness. We are deliberately lagging our announcements behind hardened systems, APIs, MCP integrations, DEX testing. So outward communication reflects operational reality rather than forward promises. In short, the direction is disciplined, clearer messaging, reduced hype risk, stronger proof points, and a community that's compounding alongside real delivery. And that's it for me for this call.
Thank you, Luke. I think it might be the first ever community call where we did a whole hour on point before the questions. So that's basically it from what we had planned to talk about. Now we're going to move over to the questions. Quite a few questions were already answered either by Hugo during his presentation or during the Integritas presentation. But we've still got a few standalone questions that I now need to look for. I'll do them in order as they came through. So to start off, we've got a question from Wadej Bey. What is the current usage status and cash flow situation of Integritas? Have you acquired any new clients in the AI sector recently? So I assume this is one for you, Adam.
Yep. Thank you. I'll take that. So we do have paying customers, a handful, on Integritas and Integritas Plus. But the main work, as was shown today, is our move towards enterprise solutions. And we are now developing a distributed API. So enterprise can have their own management keys. And we are also going to put Integritas on the Azure API management portal. So both these are gearing towards the development towards enterprise-ready solutions. Certainly, as Natalie said, we are hoping that people will use Integritas for daily use stamping, but that's why we've made it free on the API chats. But the commercial roadmap is really going to be integration where people use Integritas as part of their daily applications. And particularly, we have strong verification that the EU AI Act is going to be a case where Integritas serves a perfect functionality of keeping an audit trail of interactions of AI and LLMs, where it's going to be a requirement starting at the end of this year that all outputs from AI agents are going to have to be accountable. So there is a need, and there's an unused realization as yet, that people and companies are going to have to keep records of their AI chat history. And we are creating a simple plugin that will simply stamp and hash data. So again, true to Minima's core concept, we won't keep any private information and we won't store any of that data, but we'll act as a stamp of those functionalities. So that
can I just mention after you? Sorry,
Yeah.
after you.
Okay.
I was going to say that I'm not sure. I was. You go. I'll go after you.
Right. No, and just finally, I wanted to re-emphasize the collaboration that we're having with Relay FI. This is a newly formed entity that is creating a marketplace for APIs using the X402 protocol, which is allowing micropayments between AI agents. So this is a platform that we hope will really generate usage, and that is a very nice way of getting pay-per use. So that's our commercial roadmap.
I was going to say, actually, there were a couple of things. I mean, the Integritas team is smashing it. You're doing beautiful work, you two, just really, really good. But I wanted to mention two really viable, simple, and sort of common sense ways that Integritas could generate money for a business. And that's that eventually, when they do this, we're going to have there are two systems that still need to be added to Integritas. And the first one is that the data needs to be signed by a trusted third party. And I know we don't like the word trusted third party, but the point is that when you're the EU and when you're a business, if a business just starts putting data on the chain and say, this is that we try and stamp that data, that's fine for that business if they want to check stuff. But if the EU need more confirmation about that, what you would do is you would sign that data with the signature from a trusted third party. And that way so if a legal firm was the one that was going to get involved in this, and when you send us the data, we can actually timestamp it ourselves. We can actually make sure that the order in which you timestamp these things is correct and cannot be tampered with. I might timestamp two completely different, this is private information. We don't get to know what the data you're timestamping is. You only get to see the hash of that data. And so it could be possible for clever people, if they wanted to, that they could do two streams and they could just timestamp all the data. And so they could show whichever data they wanted to prove that they timestamped some data. But if you had somebody signing that data with a sequence number that the trusted third party came up with, then that sequence of events occurred in those events and you couldn't go back and redo it on a second stream. This is really important. And what's nice about that is that A, that's a really simple system to integrate into Integritas, and B, it's cheap, but a business, it's not that cheap. It's like £100, £200 a month, whatever. And a trusted third party would say, we'll sign that data, because we're a trust. That's what we do. We just sign the data, give you the sequence number so that you can't go back and resequence the information. That's something that a business would pay for. And that's something that the EU may actually mandate. They may say, look, we need it to be trusted by the EU governing board of signatures or whatever. And so for individuals like us, that's clearly not a thing, but for businesses, that is a thing. So that's a really nice, simple way that this might start generating some real revenue. And the second way is that we're timestamping the hash. We don't have the data. Where's all that data going to go? Who's storing all of that? You're going to need somebody who says, well, actually, what we do is we store the data that you're timestamping. You can have that encrypted, you can have it whatever you want, but you're going to need a lot of cloud storage to store the actual data that is actually being timestamped. That's another business that could be added onto this. That anybody, you looking at the community, somebody would have set this up and it's like, we offer exactly that service. So when you timestamp some data, you send it to us encrypted so we can't read it. We store that in the cloud and then we get a trusted third party to sign it and then we integrate it. That's a beautiful business, And you'd pay for that. A business would pay for that. And then it's like, right, I have all my data being stored. I have it signed by the third party. You have everything. So there's two really nice revenue streams there that could work, with the Integritas system that, that the team are working on. So that's something to look forward to.
Exactly. So in next update, we'll talk to you about the Integritas Notary service and then our partnership discussions with
service. That's it, and cloud data storage. Two great, simple, obvious businesses that could be added onto it. I love it.
So good.
All right.
Didn't want to
Thank you, guys.
give you too much in one go, so we'll wait till next time.
Giving away the game.
Moving on, another question from the same person. As for both corporate cooperation and community development in China, the promotional effects don't seem very obvious. Could Bose, the general manager of China, share any special plans with the community? I assume this is one for you, Hugo.
Sure. There is a lot of work going on in the background in China at the moment. It's coming up to Chinese New Year. And so we hope to have an update off the back of that. But again, there's lots of background legwork happening at the moment. As you know, we don't tend to shout about things until they are confirmed. So have patience and we will be coming back to you on that.
Yep. Thank you. Moving on, got a question from Jonas. Do you see a continuation of partnership with Zeekr to develop an on-demand charging solution? Adam?
Yep.
Well, yeah. So unfortunately for us, the Zika R&D Europe group
Yep.
was closed down or scaled down, and so all of the development work has gone back to China. Interestingly, we were so ahead of the game with the whole concept of tokenized payments. But now tap and pay with credit cards has become, standard. So the actual use case for Zika allowing other Zika users to use to share their wall boxes has sort of lost some of its edge. However, Zika are using tokens as part of their normal platform, but the desire for on-charge payments is still, a hot topic. And as Hugo said in his presentation, I mean, we are now positioned perfectly for the machine economy. So all of the solutions that we're talking about are perfectly in alignment with cars paying for their own charge in the future, or importantly, machine-to-machine communication and payments. So we aren't moving forward with Zika, but there are plenty of electricity providers that are looking to these solutions.
Yep.
Okay, thank you, Adam, for clearing that up.
Yep.
Moving on, we've only got a few questions left. One from Instinct. Can you share? There's two questions, so I'm going to start with the first one. Can you share whether any strategic players like ARM, Siemens, or other hardware companies are participating in this round? Hugo?
Sure. So basically, well, I mean, first thing to say is that ARM and Siemens have been very excited about the work we did on the chip development. So it is good timing, and anyway, we were waiting for that in order to sort of kick off the round. We are in talks with a number of different types of investors across both the hardware side, but also infrastructure investors as well as crypto investors. I think what we're now seeing is that it's really moving across the spectrum, and we're starting to effectively open out our sort of addressable market in terms of investors, because we're now no longer purely pitching ourselves as a crypto company, but more of a sort of infrastructure play for a trust layer for edge devices. So it is stretching across. I mean, ARM and Siemens are supporting us throughout, in terms of also we have meetings lining up with ARM and Siemens customers, and obviously that is going to be a major proof point in terms of the Series A round that we're looking to kick off towards the end of the year. And so that also feeds into this round as well in many ways. So so there's lots of stuff in there, and as we get more information, we can share it.
Yep.
Great, thank you. Second one, probably for you as well. Could you clarify whether the IP rights to the C++ Minima implementation are held exclusively by Minima AG without any external ownership interests or third-party licensing claims, like exclusive license potentially for ARM?
Yes.
So basically,
So,
everything that we are developing is Minima owned. Anything on the chip design and the designs moving on to hardware. We have had access to ARM's chip design through our partnership and involvement in the IP access program that ARM has offered. And some of these IP access has come through our collaborations with universities. But in terms of the actual IP associated with design and the hardware accelerators, that is purely Minima ownership.
Okay, thank you, Adam. And one last question from Punished Plainview. Do you happen to have a list of clients already lining up? What's the expected revenue roughly once the production of the chip? Wait, sorry, I misread that. What's the expected revenue roughly once the production, the chip, the royalties, etc., are all up and running? Hugo?
So I mean, in terms of as I mentioned, we're working with ARM and Siemens in terms of their customer base, and we're talking to some large players within the hardware manufacturing space as well. I can't go into details on those yet, as you can imagine, because we don't speculate on these kind of things. But we are working very closely with Arm & Siemens on that, and we have hopefully some positive updates on that as we go through. I mean, obviously, what we're doing in terms of revenue forecast and everything like that is, we're putting that in place so that we have a very convincing Series A at the end of the year. So we're working on those now. Obviously, the development that we've just done with the first integration of Minima within a sort of microchip environment has been really useful for us, and we've been able to sort of now use that in our sort of in the work that we're doing in order to be able to give ourselves a very compelling case for investors.
Okay. Thank you very much, Hugo. I've got two last questions for Paddy. I just need to find them. From Instinct. Wait. Oh, can't find it. There you go. So could you talk a bit about the main technical risks around the C++ implementation? Are there any areas that could realistically cause complications apart from the tight timeline you had Q4 2025? And how is the team currently testing and de-risking those parts of the system in regards to the C++ implementation in the chip of Minima?
So the only issue I have with the C++ version is that it must be 100% compatible with the Java version. That's the only real, converting code one way to the other way, they should both do exactly the same thing. So the truth is that any issues that are in the C++ version should be issues that we have with the Java version. In terms of the functionality, the memory usage, all of that stuff, that's, faster if you use C and C++, obviously, much more memory efficient, all of those things. So in terms of the actual running of the code, the C and the C++ version, I think would be better. It's just not as compatible. Yeah, we can compile one jar and it runs on everything except iPhone. Whereas on the C++ version, you have to compile each version for each different system, which is why we went with Java in the first place. That's not where the problem is going to come in. The problem is that it must be 100% compatible with the Java version. And in fact, the thing that keeps me awake at night is what if we find something where the Java is doing something that was like, oh God, it shouldn't be doing it. I mean, I don't think there's anything terribly awful going on out there, but what if one of the functions or something or whatever is different to what we thought it would be? Would we implement that with its flaws in the C, or what would we do in that scenario? And the truth is, the Java is now the canonical version. The Java is now Minima. And so everything that tries to interface with the network has to be 100% compatible with that. That's the way that it has to work. And if I may, that brings me on to just one final little thing I'd like to say is that what is Paddy going to be working on now that the DEX is sort of done? Obviously I'm fixing bugs and but what I'm actually doing is I think it's time to do the version of Minima Core. So as always, what upsets me is me. And I'm going to have a little rant about this. Sorry, I'm going to try to keep it short. But if we look at what's happening currently in the crypto space, and if you see what's happened to Ethereum and Vitalik, yeah, it's a bit of a, I like Vitalik, I like Ethereum, they've done some fantastic work, etc. But just following the guru has proved to be a bad idea. What I mean by that is that he's just said stuff and everyone's always, I love it. And here we are now, and we're throwing away L2 scaling and we're going for L1 scaling, we're throwing away, they got rid of POS and then, got rid of POW. Now they're doing POS and it's just because Vitalik says it. This idea that you should follow what the initiator says. This is the genius of Satoshi when he left. Yeah, this is the one really great thing that Bitcoin has. They don't have someone that they can go, what do you think? Because whatever you say, I'm with you. I'm down with that. Yeah, you don't want that. You want to do your own thing. You don't want to listen to, what do I know? Yeah, I'm a good techie. I'm a good coder. But as far as the direction and the this of that, forget it. Look at what Vitalik's done to Ethereum. You don't want that. So what I'm trying to do is I'm going to write a Minima Core. A Minima Core is going to be which is an offshoot of what we learned from the chip version, because the chip version was also a pure Minima version without the mini dApps, without Maxima, just an absolutely stripped down version of Minima. We need that. We need a version 1.0 Minima Core. This is it. This runs Minima. And then I'm going to lock that repo. I'm going to write that code which is, the current version of Minima is pretty stable. Yeah, no offense. I've been running mine for 6 months on my phone, no issues. I got a server that's 4 months in now. I have to update it every time I write a new version, blah, blah, blah. But when I run it, it runs. So I think we've got to a stage, there may be some little buglets or whatever, and I may have to turn the server on and off every 12 months. Okay, I can live with that. But we need to get to a version of Minima, which is like, here it is. This is it. This is the canonical version. And I'm going to lock that repo. And then from then on, I can't touch it. Because no offense, I mean, what if I lose my mind? What if I go out and I get totally drunk and I push the master? This is so bad. Yeah, I shouldn't have that access. I shouldn't have that power. There needs to be a version which no one can mess with. No one can ever screw with this version of Minima. It works. It does what it says on the tin. And that's what I'm going to be working on. And that's the version that should be the one that can be converted to C and C++. And if possible, I'm going to try and extract the different bits of Minima and make them into libs. I want KISS-VM to be a lib. I want the consensus of the chain weights to be a different lib. I want all the data units, the Minima components, the bits that we transmit over the network to be a separate lib. Then it would be much easier to convert to C. Then it would actually be like, okay, I've got all these smaller projects and they all combine to make Minima. That's what we need. And then we can lock that and we can do it. And then everybody can just use that as their, Bitcoin core. Bitcoin core, I'm a Bitcoin core man, but God damn it, they need to lock that repo. They need to stop working on that repo and say, we're locking it and we're going to start our new project called Bitcoin OG, which is all the old boys who used to work on core, and they can do that. And then you wouldn't have, it'd be much easier to then choose a different version. Currently, we all use the repo that Satoshi printed, and it's like, that has to stop. Yeah, you want multiple implementations, but you need your reference implementation that everybody has to, work with. It's like everybody knows that this is the version. So that's what I'm going to be working on after the DEX. And, that'll be good. We need that. Thank you.
Okay. Thank you for the mini rant, Paddy.
You.
Enjoyable. Now we've been live for almost an hour and 20 minutes, so we're going to wrap this up. I think it was a huge success. Thank you all for joining, both the team and the community. This will obviously go up on YouTube either later today or tomorrow. And I wish you all a fantastic rest of your day.
Cool. Thanks, everybody. Good to see
Thank you.
Thank you.
Bye-bye.
Soon.
Bye-bye.